The Voyager probes are active spacecraft that have been able to reach interstellar space and continue transmitting information. These robotic probes, which have been in space for more than 40 years, are paving the way for future explorers and providing valuable information about the structure of our solar system and what lies beyond. Voyager 1 is more than 22 billion kilometers from us, and Voyager 2 is more than 18 billion kilometers away. That's about 20 light hours. Despite the enormous distance they have only traveled about 7/100th of the total distance that the solar system occupies. They still have about 30,000 years left to cross the theoretical border of the solar system, beyond the Oort cloud. In 1977, taking advantage of a rare alignment of the planets, 2 probes left Earth that were going to make history. Voyager were going to visit the outer gas giants and also reach interstellar space. These probes are equipped with extensive scientific instruments. Although obsolete, if we compare them with today's technology, these masses of ancient space engineering are extraordinarily robust. The energy is obtained by 3 thermoelectric generators, using the nuclear fusion of plutonium-238. Getting out of the gravitational influence of the Sun is not easy. A spaceship can escape from the Earth and travel to another planet if it obtains a speed of 11.2 kilometers per second. In this way it will be launched from the Earth, although the enormous gravity of the Sun retains it in the solar system, making it spin. If we start from Earth, a speed of at least 42.1 kilometers per second is needed to leave the influence of the Sun and travel to other stars. It is the escape velocity of the solar system, and it reduces as we move away from it. It is impossible to achieve such a fast speed if it is not for gravitational assistance on other planets. The experience obtained by Pioneer 10 and 11 was very important. In 1972 and 1973, the Pioneers took off from Earth and were the first probes to achieve escape velocity from the solar system, through gravitational assistance on Jupiter and Saturn, thus demonstrating that human beings could one day leave the solar system. Although radio contact with them was lost, in 1995 and 2003, after Voyager 2 visited Neptune in 1989, the planet's gravity diverted it in the opposite direction to its sister, Voyager 1, with greater speed, at about 17.4 kilometers per second. On February 14, 1990, Voyager 1's cameras made the last and emotional image of Earth, more than 6 billion kilometers away, which exceeds the distance of Pluto. These words are based on Carl Sagan. That tiny dot over there is our home. All the human beings on Earth are found there. Those that existed, those that exist, and those that will exist. The joy and the suffering, our problems, all the wars, our ideologies and religions, every leader, king and politician, live and have lived there. In that speck of dust that floats in space, illuminated by a ray of sunday, a tiny and insignificant blue dot in the immensity of the cosmos. From now on, scientists turned off Voyager's cameras and some non-essential scientific instruments, and these to increase the useful life of the plutonium batteries. We begin to enter unknown territory. With a speed of 17.4 kilometers per second, in 1998, Voyager 1 surpassed Pioneer 10, which had an advantage of 5 years, and nothing at the moment can match this ancient device. Not even the New Horizons, another interstellar ship, since its speed is less than 15 kilometers per second, structure of the solar system. We discovered that the solar system is much more complex than we thought. It is made up of 8 known planets, the asteroid belt, the Kuiper belt, within which is the heliosphere, a teardrop-shaped region, influenced by the Sun and its solar wind loaded with particles and the magnetic field. The heliosphere is divided between the determination shock, the heliopause, and the heliosheath. In the zone of the shock determination, at about 90 astronomical units, solar activity is reduced. The heliosheath is the area between the determination shock and the heliopause that covers between 90 and 100 astronomical units. At the heliopause, the solar wind, which is full of ionized particles and atoms, joins the interstellar medium. The activity of the solar wind is reduced and compressed. It can no longer reach about 121 astronomical units. This marks the limit of the heliosphere and where interstellar space begins. In interstellar space, we are outside the region created by the Sun, and high-energy particles from other galaxies and other stars reach us. Our heliosphere largely protects us from them, and the Oort cloud is full of icy bodies, such as long-period comets and remains of the formation of the Sun. It is on average about 100,000 astronomical units, or 1.58 light-years away, full of frozen bodies, and marks the definitive end of the solar system. Before leaving the heliosphere, Voyager 2 in almost total darkness revealed many interesting data and raised many unknowns, helped to precisely determine the movement of the Sun through the galaxy, and that it is not a ball of plasma that burns and shines statically, but rather it is a large nuclear furnace of extreme power, which travels through the galaxy 724,000 kilometers per hour, orbiting the galactic center. The Sun has very powerful intertwined magnetic fields, emits a constant flow of particles, what we call solar wind, and merges with the interstellar medium. There where radiation from ancient supernova explosions exists. The solar wind forms a bubble called the heliosphere. The heliosphere protects us all, including our vulnerable DNA, from most of the high-energy radiation coming from our galaxy. That border between the heliopause and the interstellar medium is really curious, because it forms a definitive border. The solar wind with the hydrogen and helium of the interstellar medium did not mix well, and formed a gigantic bubble, and it has a radius of 100 astronomical units. There is a struggle between the pressure of solar and interstellar particles. Understanding this boundary will help us determine how other stars in the galaxy behave. If we were a solar wind particle traveling at about 400 kilometers per second, about 100 astronomical units from the Sun, we would suddenly stop at supersonic speeds. We have reached the so-called determination shock, and we are reaching the heliosheath, a part of the heliopause termination shock, and we are slowing down. The temperature increases until at about 121 astronomical units, outside the heliopause. Our speed is 0, and we evaporate. We have reached the interstellar medium, where the solar wind disintegrates. In 2012, the Voyager 1 probe crossed the heliopause and became the first spacecraft to reach interstellar space. Voyager 2 crossed the heliopause in 2018. One of the most surprising discoveries of the probes is that there is a plasma that permeates interstellar space, and that is denser outside the heliosphere than inside. This plasma corresponds to subatomic particles from other stars and supernovae. The Voyager 1 and 2 probes have yielded somewhat contradictory results regarding the limit of the heliosphere and the interstellar medium. Apparently, the density of the plasma is explained because it filters into some particles of the interstellar medium within the heliosphere, and there are no defined limits. Voyager probes have taught us that the heliosphere changes size and density over time, depending on solar activity and its location, causing it to leak. Particles from the interstellar medium are filtered into the medium controlled by the Sun. Scientists have concluded that the heliosphere protects us from 70% of the interstellar medium. Another fact to take into account is that the plasma heats up at the edges of the heliosphere, which indicates that it is compressed. Likewise, the temperature of the interstellar plasma yielded surprising results, from 30,000 to 50,000 degrees Celsius, twice as much as models predicted, and it's colder as we move away from the heliopause. The interstellar magnetic field has also surprised astronomers and extends both inside and outside the heliopause bubble, forming a kind of magnetic barrier. This makes us understand that the heliosphere is an area in constant change and more complex than previously believed, and that the interstellar medium is not completely empty. There is a lot of activity. This is the conclusion reached by Leonore Berdaga from NASA's Goddard Space Flight Center. The Sun's influence apparently extends beyond the solar system. Coronal mass ejections send charged particles into the galaxy, just like we receive from other stars. The Sun with its activity could influence the development of other civilizations in the galaxy. In fact, the gravitational influence of the Sun reaches the heliosphere, about 230,000 astronomical units from the Sun, which is about 3.6 light-years. The area of the interstellar medium and the heliopause still has many questions that Voyager will not be able to answer. Its plutonium batteries will not last forever, and are supposed to last until 2025. The waves are controlled by a team of only 10 people. Although these robust devices will last several more decades, the mission would be abandoned due to budget cuts, and they will go where no human being has ever gone. For now, the extraordinary Voyagers continue transmitting data and are like drifting ships, subject to the tides and celestial laws. They have gone further than any other ship. This is what Voyager has revealed to us about the structure of our solar system and interstellar space. Before we stop hearing them forever, We send a message to possible aliens who find them. They carry a golden disc with information about the human being, the planet Earth, music, messages and greetings of peace in 55 languages, the location of our world, and a scientific manual that can be deciphered by intelligent beings. Without any phenomenon destroying them, the Voyagers, mute and blind, will circle the galaxy without a specific destination. Voyager 2 will reach a distance of 1.7 light-years from the star Ross 248, in about 193,000 years, and Voyager 1, in about 40,000 years, 1.6 light-years from Gliese 445. Hundreds of millions will surely survive of years, much longer than humanity. And if someone finds them, the waves will leave a record of what we were able to create in a remote region of the galaxy. Our dreams and illusions were created on a tiny blue dot that we call Earth.
Hush.